Hello everyone. As you remember, the last definition that we talked about yesterday was the marginal density function. I will again write it here because I want to show some example to better understand this definition. Okay? The marginal density function of x along and x equal to integral from minus infinity to infinity fxy dy, and for y alone we have hy or integral minus infinity to infinity fx by dx. Okay? We know that we have this formula for x alone and y alone in marginal density function. Now, we have an example. We have a function like this. Fx equal to 1 over pi, then x2 plus y2 is less than or equal to 1 and 0 else. There. Okay, and also we have a shape like this. X, Y, okay. This. Okay. Also we have a shape this here. That it's in the range of the minus 1 to 1. Okay, between the radius of the circle is 1. Okay, then we can draw a plane here. Okay. Yeah, here, the shadow it. Okay. You know that here is 1 over pi. Okay, and we have x0 here. Okay, x1, and we have display here. You know that for the volume we can write. Remember we showed some examples yesterday to find the volume. For volume we can write 1 over p, the cross section of this plane, the circle, over pi, multiple area of the circle. You know that for the area of the circle, we have to find, we have to write this pi multiple r power 2 to find the area of the circle. Okay? We know that the r in this circle is equal to 1, then we have to put 1 here, 1 over 2 is 1, then we can just write pi, and then we can find number 1, that you know that from the density function, you know that it has to be equal to 1, then here we show that it's equal to 1. Now, we want to compute the marginal density. Okay, we have to find the marginal densities. You know, from this shape, we know that this area, the shaded area, is X. Okay? Imagine collapsing the y-axis. Okay. X become the area under f x y for any given x. Okay, we collapse the y-axis. Then to find the jx, that is the shaded part, we have to find the area under the fx, that we have the fxy here. We have to find the area under this axis or this function. Okay, to find this, we have, you know that yesterday we talked about that for find the volume of this part, we can draw a triangle. You remember the last example that we saw. Then we can, similar to the previous one, we can draw a circle here. Okay, and we know that the radius of the circle is equal to 1, because it's here 0 to 1, and we can easily draw it and write x0, that we have it here. Okay, x-axis. Oh, we don't need this. Then we can write it y equal to 1 minus x. X is x0, 2. Okay, for the length of line, from x0, 1 minus x02 2 x minus square 1 over x02 is 2 1 minus x. Okay, if we know all of this, then we have to find the marginal densities, or we have to find, or we can find the Jx, then symmetrically we can find the Hy. Okay. Okay. We can say shaded area is similar to that one. We can write 1 or p. It's the height of or line multiple 2 1 minus x0 2. Okay. Then for Jx equal 2 pi, because we know this 2 pi multiple square 1 minus x02, then x between minus 1 and 1. As you remember, in this shape the x was between the minus 1, we have the circle here, minus 1 to 1. Then we can say that between minus 1 and 1 we have this value for Jx, and 0 else there. Okay, we can easily write the Jx, and also due to symmetry, you can say Hy is equal to 2 pi 1 minus, instead of x0 we can write pi power 2 excuse me, when y is between minus 1 and 1 and 0 else there. Okay, just need to change the variable of the y instead of the x or x0 here to find the Hy. And you know that you can check that Jx is a proper density function. We must have, you know that for J we have minus infinity to infinity dx equal to 1. Okay? To check that it's the proper density function or not, we have to put it here, we put it here, and if it's equal to 1, that it means that's the proper density function. Okay, for check this. You know that for we have to write x minus infinity to infinity. Okay, what's the value of the jx? We know that the value of the jx is this. Then we can write in this form. Where the value of the jx is equal to this, when x is between -1 and 1. Then for this we have to write the integral in the range of -1 to 1. Okay? The jx 2 pi square 1 minus x0 power 2, and you know that's the constant. We can move it behind the integral -1 and write. I have to write the x here. Square 1 minus x0 power 2 dx. Okay. If you if you want to find this integral, we can easily see in the integral table that with Hyperbolic Shahab will give it to you. But in the integral table, we know this from integral table. It's not the part of this, but just to solve the integral, to find the value of the integral, we have to write, okay, for the 1 minus x to dx, we can, instead of this, we can write x 1 minus x2 2 plus tangent inverse x 1 minus x2. You don't need to calculate this integral from the integral table. You know that this is the result of this integral. If shall ask a question like this in the exam, with Hyperbolic, he will give you the integral table, but it's not the mathematics course, it's program. Okay, then we continue the checking of the jx, or when the x, we have the x alone. Okay, check this. We know that we have to write this. Okay, we can. So we have 2 over pi from here. Okay. X 1 minus x2 over 2. You know that the range of the integral is between -1 and 1. Then we have to write -1 and 1. We have to put -1 and 1 instead of the x here, and also plus inverse of x 1 minus x power 2 over 2 minus 1 and 1. Then you can write 2 pi. If you put it here, you usually find that 0 instead of when we put the 1 here, and 0 when we put minus 1 here. Okay? Plus tangent inverse 1 over 0 minus tangent inverse 1 over 0 over 2. You know that's the infinity. Then we can write it 2 pi pi over 2 minus pi over 2, because we know that the tangent inverse of infinity is equal to pi over 2. Okay? Then it's equal to 2 over pi. We have it here. From here we have pi 2. Okay? Then we can easily see that the result is equal to 1. Then we check this, then we know that our Jx is a proper density function, because we prove this formula. Okay? If I want to plot the the Jx, it's something like this. Plot after marginal density. Jx. Okay? We have x-axis. Okay? We have x-axis is x. This is Jx. Okay? We know that if we write it minus 1 and 1 here. Okay? Okay, I clean this, but you know that the value of the Jx was something like this. Jx equal to 2 pi 1 minus x02, when x was between minus 1 and 1, and 0 there. Okay? Then we know that before minus 1 and after 1, the value is equal to 0. Okay? But between the minus 1 and 1, we have a shape like this. You can put it 2 pi here. Okay, we have a shape like this for the Jx. 0 between minus 1 and after 1. Between in this range, we have the shape like this. Okay? Okay. Let's compute the conditional density of f by y, and the conditional density of fy when we know the value of the x, or we receive the x first, we want to find the y for example. Okay. Before to continue this part, or before to compute the conditional density, we have a definition here that we have to know this. I don't know how to talk about this or not, but it's just to learn. Okay, then. Conditional density function are defined as fy by x equal to fxy jx when jx is greater than 0, and also for fx x when we know y, we have fxy hy, then hy is greater than 0. We have already talked about this, but as you remember, we can use this definition to compute the conditional density of fy of y when we know the x. Okay, we can write it in this form. From the first function, as you remember, we have a function like this: f x and y is equal to 1 over pi x2 plus y2 less than 1, and 0 else there. Okay, it was our function, this example. Then to find this, let me write it here because here we have more space. First, we have to know that I have lots of marker, but it doesn't work. Okay, we have to know from the definition f by when we know x is defined only for those values of x for which jx is greater than 0. Here. Okay? For example, this is x between -1 and 1. That you remember that when we found the jx, it was greater than 0. Okay, and also we have to know this once we fix a particular x effect by when we know x at that is the cross section of f, x, and y at x normalized by the area under the cross section H is jx with a fixed we can have the formula for the cross section. Okay, we know that 1/pi for y2 less than or equal to 1 minus x2, because if it sent to another side of this, we can write something like this, and 0 other parts. Okay, first to finish and to find the conditional density function, then we can draw it here. Okay, x, y, fix y. Okay. I have to draw it again. between -1 and 1. Okay. Here's one we have shaped like this. Okay. And also start. Okay. Shall we this part? Okay. You know that here is 0.9. This part cross section. F when x is 0.9 and y here x is equal to 0.5 and also it was here x was 0.9 x is minus 0.5 then from this area cross section F minus 0.5 and y. Okay, from this shape we have this information. Okay, then to find the conditional density function